Mars, the last place you'd want to live. Its atmosphere is 170 times thinner than Earth's, and it's almost entirely made of carbon dioxide. Due to this weak atmosphere, there is no protection against the deadly radioactive radiation from space, especially from the sun. Practically without an atmosphere, this bare planet can't heat up properly, causing the surface temperature to range from 20 degrees Celsius to minus 125 degrees Celsius. Due to the extreme cold, there is no liquid water on its surface. However, we know that there is ice beneath the surface. The gravity is 2.5 times weaker than Earth's. Therefore, if you were to live on Mars for a while, your muscles would undergo atrophy, and your bone density would rapidly decrease. On its surface, covered entirely by fine dust, it's very difficult for even modern technology to function, let alone humans. This dust enters through even the smallest gaps and causes short circuits in electronic devices. For this reason, the vehicles sent to Mars must be designed in unusual ways. Actually, Martian soil isn't all that barren. I'll explain this in more detail in future videos. But of course, right now, we have no way of producing food on a large scale on Mars. So, if you lived on Mars, you'd be heavily dependent on food, drinks, and clothing brought from Earth. In addition to all this, even though Mars is one of the closest planets to Earth, it's still extremely far away. That makes communication and transporting supplies to Mars very difficult. And of course, since there are currently no human facilities on the surface of Mars, even the simplest medical issues, let alone daily needs, are completely impossible to manage. But despite all this, one way or another, Mars will be our next home. Because despite all the differences I mentioned and its distance from us, Mars bears an incredible resemblance to Earth. So, if we're ever going to go beyond this blue planet we live on and reach for the stars, we need to experiment on Mars and advance our civilization there. If we're too weak and incapable to even conquer Mars, we can't even dream of reaching anywhere else. First, we have to reach Mars so that we can eventually expand to other planetary systems and galaxies. So, one way or another, we need to learn how to terraform Mars, how to make it Earth-like. One of the clearest signs of a truly advanced civilization is its ability to make otherwise uninhabitable planets suitable for life. And the most important step in doing that, at least for the kind of life we know, is, of course, bringing liquid water to the planet we plan to move to. But since the topic of water in space is already widely discussed, today I want to focus on one of the two most critical things needed to sustain life as we know it: oxygen production. Because no matter how much water you bring to a planet, if its atmosphere doesn't contain enough oxygen, establishing a long-term human civilization there becomes extremely difficult, maybe even impossible. In the end, carefully trained astronauts might be able to live on the surface of Mars for a while using oxygen tanks, helmets, and specialized suits. But if we want to establish a large-scale settlement, that alone won't be enough. On any planet we plan to settle permanently, we need to make the uninhabitable areas as similar to Earth's conditions as possible. And this isn't just important for our biology, it's also crucial for our psychology. Moreover, if we can solve the problem of producing oxygen on another planet, we could combine this oxygen with hydrogen to produce water on site. This is one of the reasons scientists have been researching ways to produce oxygen on Mars for years. Significant steps have been taken in this regard so far. For instance, with NASA's Perseverance rover, the Mars In Situ Resource Utilization Oxygen Experiment, MOXIE, managed to produce oxygen on the surface of Mars for the first time. MOXIE separated the carbon dioxide, which is abundant in Mars' atmosphere, into oxygen and carbon monoxide. The individual oxygen atoms it produced later came together to create the oxygen gas we breathe on Earth. However, in order to achieve this, MOXIE used materials like yttrium, balanced zirconium, and cerium oxide 4, which are not found on Mars, and therefore need to be regularly transported from Earth. Unfortunately, this is a very common problem. If we want a viable system, we can't be constantly dependent on materials being transported from Earth. In other words, what's crucial for our future is the ability to produce oxygen using only the materials found on the surface of Mars. Because think about this. According to NASA's calculations, it's possible to transport a facility 200 times larger than MOXIE and a 30-kilowatt power unit to Mars to supply it with energy. If this can be done, 2 kilograms of oxygen could be produced per hour on the surface of Mars, which would total about 17,500 kilograms of oxygen per year. We know that a crew of 4 astronauts consumes about 1,000 kilograms of oxygen annually. This means they could easily access oxygen thanks to MOXIE. However, calling a crew of 4 astronauts a colony is a stretch. Moreover, in order for MOXIE to keep producing oxygen, as I mentioned earlier, it will need a constant supply of oxidizing materials from Earth. Also, keep in mind that oxygen isn't just for breathing. For instance, a spacecraft returning from the surface of Mars needs around 25,000 kilograms of oxygen as fuel to lift off. So, even with no losses or setbacks, the crew of 4 sent with this massive MOXIE, which currently has no replica, would have to wait at least a year and a half before they could return. Let's be honest, the idea of being trapped on Mars for a year and a half is pretty terrifying for the reasons I mentioned earlier. Luckily, Mars, although not as big as Earth, is still a massive planet. Therefore, it contains a vast amount of materials that we could use for various purposes. The key challenge is identifying which atoms, molecules, and more complex compounds we know to be present on Mars, and determining how we can combine them to produce oxygen. The oxygen evolution reactions, which result in breathable oxygen, have many different chemical pathways. The simplest method would be to produce oxygen by electrolyzing water. However, Mars isn't exactly a good source of water. Alternatively, we could break down certain metal oxides, like potassium chlorate, at high temperatures and with the right catalysts to release their 2 molecules. We could also mix a molecule like sodium chlorate with iron dust and ignite this mixture to create a chemical oxygen generator. Alternatively, we could create an environment in which plants could live on the surface of Mars and produce oxygen through photosynthesis. Moreover, due to the rapid advancements in artificial photosynthesis methods in recent years, we might not even need plants for photosynthesis in the near future. As you can see, within the richness of chemistry, there are many different ways to produce oxygen, and more importantly, each of the categories I mentioned has thousands of subcategories. Therefore, the main challenge scientists face is identifying all the reactions that could produce oxygen by examining the different combinations of chemical substances on Mars, and then filtering out the most likely ones. Scanning through so many possibilities and finding the most efficient paths and combinations is an extremely difficult task for us mortals. However, it's not as challenging for artificial intelligence. According to a recent article published in Nature Journal's Synthesis section, a research team from China has managed to overcome this challenge by using an AI system they named Chemist. And when I say artificial intelligence, I'm not talking about a program that only chats with you and draws pictures, locked away in closed servers. I'm talking about a robot enhanced with artificial intelligence that actually has a body and is powered by a chemist AI, of course. The thing controlling the robotic limbs you see in these videos is ultimately artificial intelligence. So I want to focus here on how this AI is able to think like a chemist. The researchers trained an artificial intelligence system using a total of 30,000 different hydroxide molecules in millions of different combinations to create a chemist robot. Afterward, this AI began identifying which molecules in Mars soil could produce oxygen under the influence of which catalysts. Unfortunately, the amount of samples we can bring from Mars is still negligible, so the team didn't have access to enough samples to analyze Mars soil directly. But fortunately, large asteroids hitting Mars lift significant amounts of soil from its surface, and these rocks sometimes eventually reach Earth and land as meteorites. In this way, experts analyzed the composition of 5 different Mars meteorites, known to have fallen to our planet, using lasers to identify all the chemical reactions with the potential to produce oxygen. The artificial intelligence identified 3,746,376 different ways to produce oxygen in just 2 months. Almost 4 million different ways in only 2 months. For comparison, if a single human were to do this, the process would take approximately 2,000 years. At this point, the artificial intelligence used a biased probability method to filter out the reactions that would be the most efficient for oxygen production. The final result was astonishing. The reactions identified by the AI can operate stably for over 6 days at a time, using just 10 milliamps of current per square centimeter, and a voltage only 445 millivolts higher than the voltage levels identified using thermodynamic methods. And it can do so almost unaffected by the freezing cold of Mars. If these numbers seem meaningless to you, let me explain. Based on the reactions identified by the AI, a facility we set up on Mars, if it manages to get only 15 hours of sunlight a day, with no barriers except for dust storms, will be able to produce enough oxygen to sustain itself without needing any additional materials from Earth. Humanity has begun to take its first steps toward permanent life beyond Earth. Those watching this video today will witness the first colonies on Mars tomorrow, and perhaps their children will serve in those colonies. And the most exciting thing about all these remarkable developments, in my opinion, is that when we think about humanity's future on Mars, we can no longer think of artificial intelligence as just a passive helper. Artificial intelligence will become an indispensable part of the human colonies we set up on Mars, living within them, thinking alongside them, and ensuring their survival. As you can understand, we won't be forever stuck with artificial intelligences that seem to only be able to chat with us. In the not-so-distant future, engineer AIs, chemist AIs, doctor AIs, biologist AIs will be walking among us. We will collaborate with them both on Earth and beyond our atmosphere. And that future is much closer than you think. See you in the next video. Take care.